Hello everyone, myself Ashish Desai, Assistant Professor, Mechanical Department. Today we are going to discuss here unit number 3, Fluid Kinematics. So in that content we are going to discuss here stream function. So in previous lecture we have discussed regarding the velocity potential function. In that same manner we have discussed regarding the stream function. So stream function is always remember that it is in two-dimensional form and it is useful for the finding out the fluid flow, or you can say analysis of fluid flow. So here point to be discussed here, that is stream function, properties of stream function, then numericals on stream function. So first of all we concentrate on stream function. So stream function, it is defined as the function of space and time. So space means that direction, that is x and y, that is coordinate system, and time such that its partial derivative with respect to any direction. Any direction means here only two-dimensional form is there, that's why I can take x and y, which gives the velocity component at right angles to its direction. So that is why we can take the psi is the function, that is the denotation of psi. The mathematically format, that is the defined as psi is equal to f x y, such that, so you know that x is direction of u, y is v, this is the component. So according to definition, we take dou psi by dou x. So psi means the stream function with respect to space and time, dou psi by dou x equal to, so this partial derivative equal to, so this equal to what will happen? That velocity component at right angle to this direction. So that direction is for anti-clockwise manner, y is there, right? So y velocity is v. So I can write only v. Now we take for dou psi by dou y. What will happen? Dou psi by dou y means y is direction this. And if you take anti-clockwise direction, that first direction is minus x. So for minus x, we can write here minus u. So minus u. Okay. So this is about the stream function. So only remember these two formula for stream function, that is v equal to dou psi by dou x and u is equal to minus dou psi by dou y. So this is about stream function. Now we move for the properties of stream function. So this is the formula for stream function, that is v is equal to dou psi by dou x and u is equal to minus dou psi by dou y. So first of all we write the continued equation form. So as we know that the stream function is in two-dimensional form, so that's why I can write dou u by dou x plus dou u by dou y equal to 0 and put the value of u and v over here. So what will happen? The substituting the values u and v here, dou by dou x as it is, u is nothing but dou psi by dou y, that is your minus format because minus side goes on that side, dou by dou y, then v instead of v I write dou psi by dou x, dou psi by dou x. So after solution we will get the value of 0 0 on both sides, and therefore this equation is called as Poisson's equation. And if it is exist there, then possible case of fluid flow is there, but the flow may be rotational or irrotational. So this is depending on the stream functions. Okay, now we move for the properties of stream function. So as you know that the component w, so w is your the rotational member because x and y is only the working plane, so that's why z is in that direction, rotational direction. So wz is equal to half into dou v by dou x minus dou u by dou y. So if you take x and y direction, so x value, if you take x over here, what will happen? X value, so the differentiate is to v, right? Okay, so instead of v I write dou psi by dou x, instead of v dou psi by dou x, u I can write that minus dou psi by dou y. So I put this value, only v change, u change, otherwise dou by dou y, dou by dou y, half wz. This is the same thing. Okay, now we move for the wz component, and if you take this value 0, okay, because wz is 0, because if it is component is rotational, so you can take addition of this and then final value is dou 2 psi by dou x square plus dou 2 psi by dou y square equal to 0. So this equation is called as Laplace equation. Now we move for the properties of stream function. If it is psi is exists, then flow should be rotational or irrotational. If stream function is exist and satisfy the Laplace equation, then it represents the irrotational flow. So this is about stream function. And next point is for that formula, that is dou psi by dou x equal to v and dou psi by dou is equal to minus u. So this is the formula, and calculating for the rotational member, that is wz. So wz is a rotational member, that means x and y is your the working area. So x y, so you can take z, z is green size, that's why I can write wz, and it is about x and y. Okay, so xy is x and y, and after diagonal manner u is there, after diagonal manner v is there. So this is the formulation. And for Laplace equation, dou 2 psi by dou x square plus dou 2 psi by dou y square equal to 0. So that should be presents the possible irrotational flow. Okay, so this is the formula. Now first formula, that problem is psi is equal to 5 minus 6y. Calculate the velocity components and also magnitude and direction of resultant velocity at that point. So first of all, we write the given data, that is psi is equal to 5x minus 6y. So first of all, we take dou psi by dou x and dou psi by dou y. Okay, so that value is becomes this like this. Now this component, that velocity component in terms of the stream function, is given as u is equal to minus dou psi by dou x. So only you can put the value of 5 or 6. Okay, dou psi by dou x is there. So 6. Dou v is equal to dou psi by dou x is that 5. Okay, so that 5. So this is the relation. And if you take the integration on both sides, that's why u square plus v square, that is 6 square plus 5 square, that why becomes a resultant velocity, that is 7.81 unit per second. Okay, now we move for the dimension, or you can say direction, is given by, that is tan theta is equal to v upon u, that is 5 upon 6. It gives the value of tan theta, and theta values gives the 0.833. Now we move for the next problem. So this problem is finding out the stream function from u and v, that velocities. Okay, so here the velocity components in two-dimensional flow, the field of incompressible fluid, are as follow. So first we write u and v equation and find out the psi value. So first of all, we know that the u and v values. Now this from actually the problem. So velocity components in the stream function is dou psi by dou y is equal to minus u and dou psi by dou x is equal to v. This is according to definition. So dou psi by dou y equal to minus u. So we can take directly u value over here. Okay, and this minus sign we go to the inside of this, and dou psi by dou x. So if you take the value there, v is xy square minus 2y minus x cube by 3. So if you put this directly over here, then like this, then you can take equation 2. So this equation 1 and equation 2 I can write like this. Now we shift to next slide. This is two equations. Now from equation number 1, we can take dou psi by dou x equal to xy square minus 2y minus x cube by 3. So dou x is on that side. Okay, so here we have to find out psi value. So for that purpose, we can take integration with respect to x, so that dou psi by dou x, dou psi is nothing but psi. We can take integration first of all, and this dou psi is nothing but psi. And for here xy square is there, so with respect to x, that means x square y square divided by 2, correct, minus 2xy, because it is absent, that's why we can take 2xy. Okay, then we can take integration of this, that's why x raised to 4 divided by 4 into 3 plus c. This is your the stream function. Now where c is the constant of proportionality, or you can say constant of integration, and it is independent of x and independent on x. Okay, but depending on function of y. So here I write here a differentiation with respect to y. Dou psi by dou y is equal to, so here I formulate here 2 x square y square by 2 minus 2xy x raised to 4 divided by 4 into 3 plus c. Okay, so now put the value of dou psi by dou x. Sorry, equation number 3 is here. So if you take dou psi by dou y is equal to dou psi by dou y is equal to 2x square by 2 divided by 2 minus 2x plus dou c by dou y. So now we shift from, this is actually equation number 3. Okay, so equation number 3 over here we take only dou psi by dou y is equal to that value. So after putting this value, what will happen? The dou psi by dou y is equal to 2x square by minus 2x plus dou c by dou y. So here we differentiate with respect to y, because this equation number 3 is there, only we have to differentiate with respect to y. After differentiation we will get this value, and if you get the values of the dou psi by dou x, dou psi by dou y, so here this is from definition, we can take and put the value over here, and after that we simplification dou c by dou y, we will find out this, and after that simplification only remain dou c by dou y is equal to minus y cube by 3. So you can shift dou y on that side, and after integration of this, what will happen? That dou c, integration of dou c minus y cube by 3 dy. So dou c is c and minus y raised to 4 into 4 by 3. So this is value for minus y raised to 4. 4 into 3 is 12. And substituting this equation in 3, so this equation 3 is like this, and only you have put the value of c over here. So this is regarding the stream function. So only change is over here is the, you are defining the values of the dou psi by dou x and dou psi by dou y, and then we go for this type. Okay, this is complicated manner. Now same value we have to calculate over here. Here it is given that two-dimensional incompressible fluid flow is there, and the fluid velocities component is given by, there are two equations, that is u is equal to x minus 4y, v is equal to y minus 4x. So here show that the velocity potential exists or not, and dimensional to its form, and find the stream function. So u and v is there. So I first of all we write this equation, then stream function we can write, then dou psi by dou x equal to v, dou psi by dou y is equal to minus u. So according to that basis we can write equation number 1. Similarly you can take equation number 2. So only we have to solve it. Okay, so instead of v value we can directly, we can put the y minus 4x minus y minus 4x, and if you require u value, what will u value? X minus 4y, x minus 4y, and this minus is on outside. Okay, so this is regarding the two equations. So you select any of that, that is one equation, and if you take this equation dou psi by dou x is equal to minus y minus 4x, so that dou psi is equal to minus y minus 4x bracket complete into dou x. Now we can take integration on both sides, so that will give psi is equal to minus yx, because if you take integration with respect to y, that means with respect to x is there, dou y into dou x means yx. If you take 4x, 4x square by 2 plus c. So this is regarding the stream functions. Now we find out the c value. So here c value is required, but c value is independent on, can say x, but depending on the function of y. So y function is important. Now we can differentiate with respect to y, because you have mentioned that function of y. So that's why we write for dou psi by dou y is equal to, sorry, is equal to minus x minus 0 plus dou c by dou y. So you can take differentiation with respect to them, and then we have to find out the dou psi by dou x y is equal to minus x plus dou c by dou y. And after putting this value for this equation, we will get the minus x plus 3 4y. So this is from dou psi by dou y, dou psi by dou y minus x plus 4y minus x plus dou c by dou y as it is, and after shifting the value becomes dou c by dou y is equal to 4y. So after solution, and then for finding out the value of c, we can transfer on that side. So it can integration like this, and that value gives the c is equal to 4y square upon 2. Okay, then divided by 2 is there, that's why I can cancel out. So that is c is equal to 2y square. Substituting the value in equation number 3. So equation number 3 is like this. We put the value only c. So you can take c is a 2y square. After the putting this value, the psi is equal to equation becomes minus yx minus 2x square plus 2y square. Only put the value of c over here, that is 2y square. Now the next problem, that is if the expression for stream function is described in a psi is equal to x cube minus 3xy square, determine the flow is rotational or irrotational. So you have to identify here rotational flow or irrotational flow, and if the flow is irrotational, then incorrect value of velocity potential is. So first of all we write this equation. This is first equation. U is equal to dou psi by dou x, v is equal to minus dou psi by dou x. So here y and x is there. After putting that v, that is psi is there, what is x cube by x cube minus 3xy square, and if you take differentiation like this, so only remain minus 6xy. If you take v, what will happen, dou psi by dou x, x cube minus 3xy square, so that's why 3x square is there, that's why 3x square minus here 3y square. Okay, so this is value of u and v. Now we take the rotation about this, because you have to identify rotational or irrotational. So that wz is equal to half of the dou v by dou x minus dou u by dou y. Okay, so put the value of v. So v is here, so we want dou u by dou x. So dou u by dou x means only minus 6. So after simplification, dou v by dou x equal to minus 6x. Similarly we can go for u is equal to minus 6y. So you can differentiate with respect to here we can take with respect to y. So I can put y, that value becomes uh, dou u by dou y equal to minus 6. So this curve, that bracket indicating the value of dou u by dou x and dou u by dou y. So you can put the minus 6x over here, and after putting this value we will get the wz equal to 0. So that means the equation there, the rotational is component is 0, that means irrotational flow is there. And after this checking the availability of phi, we can take the phi is equal to y cube minus 2xy square. Then we can take differentiation with this 2 times dou 2 phi by dou x square. Similarly for dou 2 phi by dou y square. Okay, and a Laplace equation, as we know that dou 2 phi by dou x square plus dou 2 phi by dou y square equal to, we can take the y cube minus 3xy square. Okay, minus that, instead of this we can get minus 6xy, then plus 6xy, so we can take 0. That means here we can take next point, that is phi is equal to minus 3x square x square y. If you take differentiate with respect to dou 2 phi dou x square, minus 6y is there, so dou 2 phi by dou x square, this minus 6y we can take on that side, 0 is on that side, so that's why minus 6y is there, that's why it is not equal to 0. Okay, now hence here the value is between y cube minus 3xy square and minus 3x square y. So this value is important, that is why we can take correct value. Okay, now we move for the flow net. The flow net is obtained by drawing the lines of streamlines, and equipotential lines is known as flow net. The flow net provides a simple graphic technique for studying the two-dimensional form, as well as it is whenever it is complicated form, that is stream function and velocity function, we can go for flow net. So this is easier method. So first of all we know that the methods of drawing flow nets. So first is analytical method, second is graphical method, third is electrical analogy method, fourth is hydraulic models. So first of all we discuss regarding the analytical method. So in that equation corresponding to the curves phi and psi are obtained, the same are plotted to give the flow net patterns. So this method is applied for the problem with special, simple and ideal boundary conditions. So this is only the flow pattern. Now we move for graphical method. So in that we considering the drawing streamlines and equipotential lines that which cut the orthogonally and form curvilinear squares. So this is the graphical method. Now we move for electrical analogy method. So as soon as this method is appropriate for drawing of flow nets for particularly set of boundaries. Then second, it is based on the fact that can be flow of fluids and of fluid of electricity through a conductor and analogs. So this is regarding the electric analogy. Last one is a hydraulic model, so that can be injected or traced by the injecting die and sievage model or Hillis-Shaw apparatus. So this is the formulation we have to observe here. Now we have to find out this typical nozzle nets. Now we know that the use of flow net, it is determine the streamlines and you can see equipotential lines. And second, for to determine the quantity of seepage and uplift below the hydraulic structure, to determine the velocity and pressure distribution, to determine the design of outlets for the streaming. This is important point, to determine the design of outlets for the streaming. Limitations for the flow net. So first of all, the first limitation is the flow net analysis can be applied in the rest region close to the boundary where the effects of viscosities are predominant. Second, in case of flow of pattern, the solid body, while the flow net gives the fairly accurate pictures of the flow pattern, and it gives little information concerning the flow conditions. So this is about the limitations. So already we discussed regarding the this advantages point that is in the application. Then limitation we have discussed this. Thank you.